Hello everyone, welcome to my new video. So this video is all going to be about search in a binary search tree. So we are going to see how search operation happens in binary search tree. It is a very easy problem, but it also at the same time it's a very important concept if we want to solve for the problems on binary search tree. So let's get started. First thing is that you are given the root of binary search tree and an integer val. Find the node in a BST such that the node's value equals to val and returns a subtree rooted with that node. If such a node does not exist, return. Yeah. So here we can see that we are given a binary search tree 42137. We will be given a value that we need to find out in a binary search tree. So let's say we need to find out 3 in this binary search tree. So we have to perform some operations in a way that it will go and return the subtree after that value. Okay. So what is the basic property of binary search tree? Basic property of binary search tree is that all the all the values lesser than the root will be on the left side, and all the values bigger than the root will be on the right side. So this is the basic property that we need to keep in mind while solving these problems. Okay, so let's go ahead and start solving this problem. I think we can try some different approach this time. I'll be writing code and I'll explain what I'm doing. But after that, I'll also go through the dry run of the code to understand what exactly is going through inside this binary search tree. So let's get started. So first thing we need to do here is we need to just write the termination condition first. That if root is equal to null PTR, then simply root return okay, PTR and return. Now, what's the second thing that we need to do? We need to make sure that we write the efficient code and clean code. Okay, so second thing is that if else if we have found the element, let's say we have found the element that we're looking for, that means root val is first to val, and just simply return up. We need to keep two conditions in mind if it is bigger than the root or if it is lesser than the root. If it is bigger than the root, then we will go to the right side, we will traverse to the right side of the tree. If it is lesser than the root, then we'll go to the left side of the tree. So else if root's value is val greater than val. So in this case, we will just return search PST roots left. So that means we are going towards left and right. Now the last condition is return search. The only thing that is left is to go to the right side if it is bigger than the root. So root right and val. That's it for the code. If we run this code, see how it gets. Solution. Maybe I just missing the bracket here. Should be fine after that. Okay, perfect. So now we are doing the recursion function here. So now let's go to the whiteboard and see how this is working in actual. Okay. So whiteboard dot is going to write draw subtree here 4721. So 4 and 7 and 2 4 7 2 on the left side 1 and 3 should be here. Okay. Let's just draw the lines first to make sure. Yeah. That's not looking very beautiful, I know, but it's just for the demonstration purpose. This is 2, just to make sure. Okay. Now, let's go and see what is actually happening in our code. So we have the root value. We have root and we have value. Value that we have to find, let's say, is equals to 1. We have to find 1 in this binary search tree. So in the beginning, in the very beginning, root is going to be here, okay, at 4. Now we need to, let's go to the code. First of all, check if it is null or not. It is definitely not null. So we are going to skip this. Now check if it is equal to the value. Is 4 equal to 1? No, it is not. It is not satisfying the condition yet. So we will go back to the next line of code. So root's value is greater than 1. Is it greater than 1? Is 4 greater than 1? Yes, it is. So now what we will do is we will move our root here. We will move our root here to 2. So now it equals to 2. Okay, so now this is the recursion condition. So now we will run the same function by assuming that 2 is the root. So let's start over again. First of all, check the null condition. No, it's not null. Is it equal to 1? It is not. So now one more time, we have to come here and see, is it greater than value? Yes, it is greater than value. It is greater than value. So what we're going to do is, yes, 2 is greater than 1, right? So what it is going to do? The root will be now here. Root will just simply. So now as root is here, let's run the, so it is doing the recursion one more time. So let's do it one more time. If root is personal PTR, no, it is not. Is it equal to value? Is 1 is equals to 1? Yes, it is. So it is just simply going to return root. And here is the element that we have, that we were supposed to find. So this was all about the search operation in a binary search. It was a really easy concept, but it is very important to know what actually is going on in the basics. So with the help of this operation, we can probably solve all the further problems in binary search tree easily if we know what the basics are. So yeah, it was all. And thank you so much for watching. And yeah.